Have you ever wondered why the vast expanse of space is pitch black despite the glaring presence of the sun? It's a question that has perplexed many, a riddle that seems to defy logic. After all, the sun, our closest star, is a massive ball of burning gas, shedding light and warmth onto the universe. Yet space, the infinite canvas on which this majestic star paints its light, remains shrouded in inky darkness. This intriguing darkness isn't just a matter of simple curiosity. It's a fundamental puzzle, a cosmic conundrum that involves the very nature of light in space. It's a question that compels us to explore and understand the interplay between the sun, the beacon of our solar system, and the vast silent expanse of space that exists beyond our world. Our journey begins here, at the threshold of this question, poised at the edge of understanding. So, buckle up, as we delve into the fascinating science behind the darkness of space. Our sun, a massive ball of raging heat and light, illuminates our world, but why doesn't it brighten the whole cosmos? The sun, much like other stars, is a colossal nuclear furnace, relentlessly emitting waves of light and heat. This radiant energy travels in straight lines, radiating outwards in every direction. Picture it like an immense lighthouse, its beacon slicing through the darkness and revealing what was once hidden. Now let's consider how we perceive light. Light is not something we can see unless it hits something. When the sun's rays strike the moon, Mars, or even our home planet Earth, we see those objects because they reflect the sun's light back to us. Essentially, the sun illuminates planets and objects that it directly hits, painting them in vibrant hues for us to marvel at from afar. So, if the sun lights up everything it touches, what happens in the vastness of space? Space, a seemingly infinite void, stretches beyond our wildest comprehension. But what is it about this void that swallows the sun's light? Imagine the space as a vast empty stage where the sun and the stars are the performers. The light they emit is the music, the rhythm, the performance itself. But unlike a traditional stage, this one is devoid of an atmosphere. It is in essence a vacuum with very few particles to scatter the sun's light. So how does light travel in space? It's a bit like asking how sound travels in a room. Light, like sound, is a wave, and it needs no medium to travel. It moves in a straight line until it encounters an object or particle. When we see the sun's light here on Earth, it's because our atmosphere is filled with countless particles that scatter the sunlight in all directions, illuminating our world. But in space, there are far fewer particles to scatter the light. As a result, most of the light from the sun and the stars travels unimpeded through the void, never reaching our eyes unless we are directly in its path. That's why, despite the presence of countless stars, space appears black. Now you might be wondering about the interstellar medium, the matter and radiation that exists in the space between the star systems in a galaxy. This includes gas in ionic, atomic, and molecular form, as well as dust and cosmic rays. It's true that this medium is there, but it's incredibly sparse. In fact, the interstellar medium is so thin that it's still a better vacuum than we can make on Earth. And what about space dust, you might ask? It's out there, but it's not enough to significantly scatter the sunlight. So the vast majority of the light from the sun and the stars passes through this dust unscattered, leaving space to appear as a dark void. The void of space, it seems, isn't as simple as it first appears. The apparent paradox of a sunlit yet dark space starts to unravel when we explore the principles of light and color. Our eyes, you see, are quite the marvels of natural engineering. They're designed to perceive light that directly enters them, allowing us to see the world around us in vibrant hues and shades. But here's the catch: if light doesn't directly enter our eyes, we don't see it. Let's apply this principle to the vast expanse of space. It's filled with countless stars, each one a blazing sun emitting light in every direction. Yet unless that light from a star is directly entering our eyes, we don't see it. It's as though the light doesn't exist at all. And that's the key to understanding why space appears dark. Now you might be thinking, shouldn't the light from all those stars eventually reach us, filling the universe with light? This brings us to another fascinating concept, ERS Paradox. Named after the German astronomer Heinrich Wilhelm Olbers, this paradox asks why, if the universe is infinite and filled with an infinite number of stars, is the night sky dark instead of ablaze with light? The answer lies in the ever-expanding universe. It's a concept that's a bit tricky to wrap our heads around, but the universe is constantly expanding. This means that many stars are so far away, their light hasn't had time to reach us yet. And the light from some stars will never reach us at all because the universe is expanding faster than the speed of their light. So even though the universe is teeming with stars, their light is either not directly reaching our eyes or is still en route, giving us the illusion of a dark, empty space. Even in the seemingly endless night of space, there's a logical and scientific explanation for the darkness that surrounds us. Our cosmos, with its sunlit planets and dark voids, is a place of endless wonder and fascinating science. We've embarked on a journey today, uncovering why space, despite being bathed in the light of the sun, remains shrouded in darkness. We've understood that the sun, our closest star, emits light in all directions. But space, the vast expanse between celestial bodies, is largely empty, offering nothing for the sun's light to interact with or reflect off. This absence of matter results in the perceived darkness. Moreover, we've delved into the principles of light and human perception. Our eyes, sensitive to visible light, can only perceive light that directly reaches them. In the void of space, only direct, unscattered sunlight can reach us, making distant space appear dark. Finally, the universe's relentless expansion plays its part too. It stretches and dilutes light, contributing to the darkness we observe. So, the next time you gaze up at the night sky, remember the incredible science that explains the darkness of the cosmos, even with the sun's light streaming through it.